Welcome to 321 exams. Today I shall be your physics teacher and we shall be talking about the topic temperature and its measurement. In the course of discussing this topic, we shall be talking about what temperature really means and some of the terms used in this subject matter, how to measure temperature and every other parameters that are related to this concept of temperature. Now, the first thing we want to talk about as far as temperature and its measurement is concerned is the concept of temperature. Under this concept, we talk about the definition of temperature. And this leaves me with a question: what is temperature? From your elementary knowledge, you might say temperature is the degree of hotness or coldness of an object or a body. Yes, you're either hot or cold, no matter what it is, right? And the standard temperature is relative. What I mean by relative is the sense that, or is the fact that the temperature, the standard temperature for Nigeria is different from in other countries because of the change in the weather or the differences in the weather. Is that understood? Now, for this reason, you can define temperature as the degree of hotness or coldness of a body. It can also be defined as the measure of the average kinetic energy of a body. Now, leave me with this definition. Let me give you something to go home with, right? Temperature. Temperature is the degree of hotness or coldness of a body or an object. This is the first definition of temperature, the degree of hotness or coldness of a body. Now, I'll give you another definition here. It is the measure of the average kinetic energy of the body. Of a body. That is the second definition of temperature. It is a measure of the average kinetic energy of a body. Now, let me take your mind back to what kinetic energy is all about. Kinetic energy is the energy related to motion. Now, when you're moving, the velocity increases as well as the kinetic energy, because the definition of the kinetic energy is the energy attributed to a body due to its motion. Why that attributed to a body due to its position is the potential energy. And for the fact that kinetic energy is related to the velocity, because the increase in velocity automatically causes an increase in the kinetic energy. No wonder the kinetic energy is given by the formula Ke equals to half mv squared. On this note, you can now realize that the kinetic energy is proportional to the velocity. Therefore, an increase in velocity increases the kinetic energy of a body. So if you want to take a look at the measure of the average kinetic energy of a body, then you're talking about the temperature. Remember, the temperature is different from heat. Heat is the measure of the total internal energy of a body, right? While the temperature is a measure of the average kinetic energy of a body. Heat is a form of energy. Temperature is not a form of energy, right? It is measured in joules because it's a form of energy. Temperature is measured in degrees Celsius, Kelvin, or Fahrenheit, and so forth. And there is heat, or heat occur due to the change in temperature of a body. And that is why you can confidently say that a place is cold or a place is hot. Your definition of coldness or hotness has to do with the temperature of that particular place compared with the temperature of your body. Is that clear? Then the next thing we want to talk about is the measurement of temperature. How do we measure temperature? Temperature can be measured using the instrument called the thermometer. So this is the instrument used for measuring temperature, right? And we have different types of thermometer, which we shall be considering in the next slide We have the liquid in glass thermometer. We have the resistance thermometer. We have the gas thermometers, and so on. And each of these thermometers has the liquid they operate with, and this is called the thermometric liquid, right? We'll talk about that in the next slide. But what I want you to understand as far as measurement of temperature is concerned is the fact that temperature can be measured using this instrument called thermometer. And that is why when you go to the lab or to the hospital, whenever you are a bit ill, the first thing they do is to check your temperature using that thermometer. The thermometer they use in hospital is what is called the clinical thermometer, right? And we also made to understand that the average body temperature is from 35 to 40, right? 36.9 is absolute, which is approximately 37, right? So from 35 to 43, you have the temperature range of a normal human body. Is that clear? Temperature also can be measured in degrees Celsius, Kelvin, or Fahrenheit. And in our next slide, we shall be looking at the relationship between these units for measuring temperatures, right? So I want you to go home with something today that the temperature can be measured using the thermometer, and it can be measured in degrees Celsius, Kelvin, or Fahrenheit. Now, we want to talk about the different types of thermometers, including their thermometric liquid and the properties. Now, the first thermometer I want to talk about is mercury in glass thermometer, which falls under the liquid in glass thermometer, right? And an example is a clinical thermometer. That is the thermometer you use in your hospital, or for those of you who are perhaps ill and you go to the hospital for the temperature measurement. The thermometric substance used here in mercury in glass thermometer is mercury. And remember, mercury is one of the metals that exist in liquid state, right? And the physical properties of this substance is increase in volume of mercury with increase in temperature. When you get to the hospital, perhaps you're ill, the first thing they do, as I said earlier on, is to measure your temperature. And immediately they insert the thermometer and it reads your temperature. They take the difference between the original level of the mercury in the thermometer and the final level, and that gives you the temperature, right? Now, if your temperature exceeds a normal temperature, then you'll be declared ill, and that calls for admission, right? So the properties here is the increase in volume. Remember from my earlier explanation, I told you that the change in volume of the liquid gives the temperature of that particular body. Therefore, the physical properties of the thermometric substance used in mercury in glass thermometer works on the principle of increase in temperature on the volume of mercury with increase in temperature. I hope that is clear. Then the next is the gas thermometer, and the thermometric substance used is a gas. You might be wondering how this is possible. Then you go back to what is called the gas law that we treated earlier on. Now, the pressure of a gas at constant volume, or the volume of a gas at constant pressure, gives you the principle of the physical properties, rather, of that thermometric substance, right? The change in pressure at constant volume, or change in volume at constant pressure, right? And also, I want you to remember that under Boyle's law, we talk about the relationship between the pressure and volume. Boyle's law is a topic under the gas law, which we did some time ago. So with this, I believe you understand this concept of pressure, volume, and perhaps temperature. The next thermometer I want to talk about is the thermoelectric thermometer. This works on the principle of a thermocouple, right? And the thermometric substance used is the current flowing. Yes, in the introduction to this physics, I made mention of the difference between the current and the voltage. And if you want to know more about that, please go back to the measurement, right? Now, the physical properties of the thermometric substance is one junction of two dissimilar metals is heated. That is, when two dissimilar metals are heated at one junction, then we have the physical properties of this thermometric substance, which is used in the thermoelectric thermometer. And the last part we want to talk about is the resistance thermometer. And the thermometric substance is the resistance of the current. Remember that under current electricity, you are told about the definition of resistance, that this is the opposition to the flow of current. That is, that quantity that tends to oppose the flow of current is called the resistance. And that is why conductors have low resistance, because current flows through them easily, while insulators have high resistance because they offer greater opposition to the flow of current, right? And the physical property is the increase in the resistance of a metal wire when the wire is heated. Under semiconductor, you'll be made to understand that increase in temperature of metal tends to increase the resistance of that metal and reduces the conductivity. But in a semiconductor, an increase in temperature tends to increase their conductivity as well as reduces their resistivity. So with this, we have come to the end of the thermometers and their thermometric substance. Then the next thing we want to consider under this aspect is the fixed point of thermometers. There is a fixed point that is called the upper fixed point. The upper fixed point is the temperature of steam from boiled water boiling at normal atmospheric pressure. Temperature of steam from pure water boiling at normal atmospheric pressure. And remember that the temperature of the boiling water is 100 degrees Celsius, right? And that is the temperature at which water in liquid form is converted to steam in vapor state, right? And that is why you see 100 degrees Celsius written here. Lower fixed point, this is the temperature of a mixture of pure ice and water at normal atmospheric pressure. You all agree with me that the temperature of the pure ice is 0 degrees Celsius, right? And when the pure ice is converted to water, it still maintains that temperature of 0 degrees Celsius before an increase in temperature, right? So when you have the ice and water, this ice at 0 degrees Celsius to water at 0 degrees Celsius, here the conversion it's brought about by what is called the latent heat of fusion, right? Now let's go to the fundamental interval. This is the difference between the upper and the lower fixed points, right, of thermometers, right? So when you take the difference between the upper and the lower fixed points, then you have the fundamental interval. Then the next thing is the scales of temperature. I said it in the earlier slide that temperature can be measured in degrees Celsius, Fahrenheit, or Kelvin scale. And the relationship between them is 5/9 degree Fahrenheit minus 32 will be equals to degrees Celsius, and degrees Celsius plus 273 will give you the Kelvin scale. So this is the relationship between the Fahrenheit, the Celsius, and the Kelvin. So if you want to establish a direct relationship between the Fahrenheit and the Kelvin, then we can make use of this, right? 5/9 degree Fahrenheit, so this is the first, this is the second, minus 32 will give you degree Kelvin, degree Celsius will now give you Kelvin minus 273, right? So we have 5/9 degree Fahrenheit minus 32 plus 273 will give you the Kelvin. So this gives you the relationship between the Fahrenheit scale and the Kelvin temperature scale. Now, before we proceed further, let's take a look at the qualities of a good thermometer. The quality of a good thermometer is what we want to talk about now, because for you to be able to identify a thermometer as being a good one, it must possess some certain characteristics or quality. The first thing is eye sensitivity. That is, it must be sensitive to change in temperature or to temperatures, right? It must be easy to read. That is why we have the easy readability. And this is a reason water is not used as a thermometric substance, because it cannot be easily read, right? Water is transparent, so even in a thermometer, you can't actually see water there meaning it is not easily readable because of its transparent nature, right? So that is one property of a good thermometer. The next thing is accuracy over a wide range of temperature. This is also a factor that disqualifies water from being used as a thermometric liquid, because the temperature range of water is from 0 to 100 degrees Celsius, and for that reason it's a small range, and that is why you don't use it, because you can't use it to measure temperature above 100 or less than 0 degrees Celsius. Now it must have a high boiling and melting point. Now this is what we are saying. For you to be able to use a thermometer or a good thermometer, for you to be able to state that the thermometer is a good one, it must have a high boiling point. That is, it must be able to measure a far extreme temperature and also the lower temperature too, right? Alcohol is very good at this. It has a high boiling point, and that is why it is used in most thermometers, but its melting point is not as low as that of alcohol. I'm talking about mercury for now, sorry. Its melting point is not as low as that of alcohol, and that is why alcohol is used in temperate, in cold region. That is where the weather there is extremely cold, to measure temperature, because alcohol can be used to measure a relatively low temperature compared to mercury, while mercury can be used to measure a very high temperature compared to what? Alcohol. So this is one advantage alcohol has over mercury, and also one advantage mercury has over alcohol. Alcohol can be used to measure low temperatures, while mercury can be used to measure high temperatures. Now let's look at the advantage here. Advantage of alcohol over mercury. Alcohol freezes at minus 115 degrees Celsius. You know what that means? In a very cold region, right, like the polar region or anywhere that is very cold, you make use of alcohol in glass thermometer. You don't make use of mercury in glass thermometer, because mercury cannot be used to measure extremely low temperature, right? So therefore, one property of a thermometer too is that it must have a low or an extreme low temperature, like alcohol, so that you can use it to measure low temperature too, compared to mercury that can be used to measure high temperature, right? And can be used to measure extremely low temperature. So use this in those regions where we have snow or ice, right? Then number 2, expansivity of about 6 times that of mercury. So alcohol has high expansivity compared to mercury. Now, considering the fact that this occur in liquid state, then we'll talk about the volume expansivity, right? So the expansivity of alcohol is about 6 times that of mercury. That is another vital point or advantage of alcohol over mercury, right? Now let's consider the advantage of mercury over alcohol. Mercury, unlike alcohol, is not easily vaporized. Remember, most of your alcoholic liquids are made up of alcohol. They contain high percentage of alcohol. For instance, your methylated spirit. If I decide to drop methylated spirit on the back of my hand, before you know it vaporizes, right? It evaporates easily, right? This is what mercury doesn't have, and that is one advantage of mercury over alcohol. Mercury is opaque, is silvery colored liquid, and can be clearly seen. Remember, when we talk about the qualities of a good thermometer, we said easy readability. Your ability to be able to read the meniscus correctly and clearly is one attribute of a good thermometer. And this man called mercury has it, because it's silvery color or silvery in color, or it has a silver color, then it can be easily seen. Then the next thing is adds much conductivity and respond more rapidly to temperature change. Now, this accuracy over a wide range of temperature also has a lot to do with the conductivity, right? Because when a liquid has a high conductivity, then it responds to temperature change, right? So that is one advantage of mercury over alcohol. It has much conductivity and responds more rapidly to temperature change. Alcohol too has, but it's not as high as that of mercury. And the fourth advantage is that it does not wet glass. One of the reasons you don't use water as a thermometric substance is the fact that it's wet glass. It's wet glass because the force of addition of water to glass is greater than the force of cohesion of water molecules. So it's wet glass. But mercury does not wet glass because of the force of cohesion of its molecule is greater than the force of adhesion to glass. We'll talk about that when we get to structure of matter and elasticity. Right? So these are the 4 advantages of mercury over alcohol, why alcohol has 2 advantages over mercury. But in a nutshell or in summary, you use mercury to measure temperature, like in Nigeria, in tropics, right? Where you know the temperature is moderate, it's not too cold, but we can have an extreme high temperatures. But when we go to some of those temperate countries, right, like the Russia and so on, where we have extremely low temperatures, then you make use of what? Alcohol in glass thermometer. Now, before we go to the next slide, I would like to talk to you about the fact that this quality of good thermometer came out in 2018, and the question number is 21, and it also came out in 2011. Now, let's go. Water is not used because it's wet glass, it does not expand uniformly, it is colorless, and it has small range of expansion. I explained that in the earlier slide. And I believe with this, we have come to the theoretical aspect of this temperature and its measurement. Now let's go to the practical aspect, which involves solving questions, right? Please, I need you to be very attentive here so that you can get virtually everything I will be talking about in this aspect. Solution. A platinum resistance thermometer, you see, we are discussing now a resistance thermometer, records 3 ohms at 0 degrees Celsius. Definitely from here, you realize that the lower fixed point is 3 ohms and 8 ohms at 100 degrees Celsius. That is, the upper fixed point is 8 ohm. If it records 6 ohm in a certain environment, the temperature of the medium is what? Now we have a general formula guiding this calculation or question of this nature, and I'm going to be stating that for you here. But before I do that, let me illustrate this question in a diagram. This is the upper fixed point, that's 100 degrees Celsius. This is the lower fixed point, 0 degrees Celsius, right? At 100 degrees Celsius, it is 8 ohm. The resistance thermometer is 8 ohm. At 0 degrees Celsius, the resistance thermometer is 3 ohm. Now, this is at a temperature which you don't know, x degrees Celsius, and we have the thermometer to be 6 ohm, right? So this is the diagrammatic representation of the question. Now, let's go to the formula or the principle governing the solution to this question. We have x minus 0, that is that temperature minus the lower fixed point, over the temperature of the upper fixed point minus the lower fixed point, equals to the resistance as x, which is 6, minus lower fixed point is 3, over the resistance as 100, which is 8, minus the resistance as lower fixed point, which is 3. I'm going to be solving this using another method. That is, if this is not clear enough, right? So we have x over 100 equals to 6 minus 3 is 3 over 8 minus 3 gives you 5. When you cross multiply, 5 times x is 5x, will give you 100 times 3. So that 5x will be equals to 100 times 3 is 300. Then x will give you 300 over 5, which is 60. So the temperature there is 60 degrees Celsius, right? Then the other method you can use is, this is method 2 now. Temperature at that value minus temperature at lower fixed points, which is, we don't know, That's at 0 degrees Celsius. So since we are dealing with the resistance, so it's going to be the resistance at that temperature we don't know, which is 6, minus the resistance at the lower fixed point, which is 3, over the resistance at the upper fixed point, which is 8, minus the resistance at the lower fixed point, which is 3, then everything multiplied by the temperature difference, which is 100/1. That is the temperature difference between the upper and the lower fixed point. And here it's going to give you 3/5 times 100/1. So 5 here 1, 5 here 100 gives you 20. And 20 times 3 gives you 60 degrees Celsius. So with any of this method, you realize that we'll still arrive at the same answer, which is 60 degrees Celsius. The first method, you compare the different temperatures as well as the different resistances. The second is going to be the resistance at that temperature minus resistance at the lower fixed point over the resistance at the upper fixed point minus the resistance at the lower fixed point, then everything times 100/1, which is the difference between the temperature of the upper fixed point and the temperature of the lower fixed point. So this is the first example, and this example was extracted from JAMB 1998. Now we're going to the second example. It's still the same technique we are going to be employing here in solving this example, right? Now the length of the mercury thread when it is at 0, 100, and at an unknown temperature are 25 millimeter, 225 millimeter, and 175 millimeter. So the first thing we need to do is to draw this, or we represent this in the diagram, right? So let's say this is the 100 degrees Celsius. This can be anywhere. This is X degrees Celsius, and this is 0 degrees Celsius, right? Now we'll talk about the temperatures. At 0 degrees Celsius, which is the lower fixed point, that is 25 millimeters. At 100 degrees Celsius, that's 225 millimeters. That's the length of the mercury thread. While at the unknown is 175 millimeter. I'm going to be sticking to the first method, but you can decide to use the second method. You still arrive at the same answer, right? That is, we have the temperature at that unknown point minus lower over 100 minus lower. 100 is the upper, remember, equals to what is the length at that point? 175 minus 25 over length at 100 is 225 minus 25, right? So that will give you the length at that unknown temperature minus the length at the lower over the length at 100 minus the length at lower, right? And that gives you what? X over 100 equals to 175 minus 25 will give you 150 over 200. When you cross multiply, we have 200x, we give you 150 times 100, right? So x will give you 150 times 100 over 200. These two cancels out. 2 here 1, 2 here 150 gives you what? 75. So the temperature there is 75 degrees Celsius. With this, gentlemen and ladies, we have come to the end of this lesson. See you in the next lesson, and bye for now. Thank you.